In this video, we're going to continue our work with the equation of a straight line and look at some exam and extension questions. Some of these might be beyond the scope of your course, so if you want, you can just see them as a bit of a challenge or some extension material. Let's start off. We're told two straight lines are shown. We need to prove that the lines never meet. So here are our two lines. If they never meet, they will be parallel and their gradients will be equal. So we can write now if they never meet. So if they never meet, and I'm just going to jot this down to the examiner, if they never meet, they will be parallel. They will be parallel, and I'm going to use the notation for parallel, and their gradients will be equal. So their gradients, so just jotting this down, their gradients will be equal. So this is my opening line, and I'm going to go ahead and try and show that they will have equal gradients. I'm going to call this one L1, so that's line 1, and this one L2. Just completing the coordinates, 0, 2, we got 0, negative 3, and 9, 0, or 9, 0. So let's now think about line 1. Line 1, we can find M1. That is the gradient. The gradient, as we know, is the change in y over the change in x. The change in y is going to be 4 minus 2 over the change in x, which is going to be 6 minus 0. So that's going to give us now 2 in the numerator, 6 in the denominator, which gives us a simplified fraction of 1/3. Let's now go ahead and look at line 2. We can say M2, which is the gradient of that line. The change in y, 0 subtract negative 3. So we'll have 0 subtract negative 3 over the change in x, which is going to be 9 minus 0. So if we just look at that numerator now, we've got 0 and we're subtracting negative 3, which will give us a positive, over 9, and we can simplify this to 1/3. We can write at this stage M1 is equal to M2, which is equal to 1/3, and using my notation, therefore they're parallel and never meet. So, and never meet. And that's a nice way to conclude that one. So all we've done is shown that the gradients of these two lines are the same, therefore they're parallel, and they will always have the same distance between them. So the distance just here will be exactly the same as the distance just here, and so on and so forth. So they remain now parallel. So quite a nice question, and fairly logical on that one. On this one, it says on the grid, A is the point 0, 1. The midpoint M of AB is 2, 7. We're asked to work out the equation of a line through C that is parallel to AB. For the equation of a line, we need two things. We need a point that it goes through. We don't need the y-intercept. We just need a point, and we need a gradient. That's all we need for the equation of a straight line. So let's go to work. Firstly, we can say that the gradient of the line through C will be the same as the gradient of the line through AB. Also, we can find now the coordinates of C if we find the coordinates of B. We can see now that the x-coordinate of C is going to be 0, and then we'll have some y-coordinate. With B, we're going to have some x-coordinate, and we will have the same y-coordinate as C. So these two are going to be the same. We're told this is the midpoint. So the first thing I'm going to do is find the coordinates of B, and then use that value of the y-coordinate to find the coordinates of C. A nice way to look at this is a midpoint. I've jumped up by 2, I need to jump up by another 2. It's not really important that we get the x-coordinate here, I'm just going to do it for completeness. So we can see that that's going to be 4. More importantly, if I look at the y-coordinate, I've jumped up by 6, so I need to jump up by another 6. Plus 6 and plus 6, so that's going to give me 7 plus 6, which is 13. Therefore, we can simply say that C is going to be 0, 13. You could, of course, use the midpoint formula for that, although I think with this graphical representation, it's a lot easier. So we've now got a point that it goes through, and that is 0, 13, and that is the point C. What we now need is a gradient, and the gradient we call M. We've got this line, and we can see these are parallel, and we're told they're parallel. What I'm going to do is find the gradient of this line. I'm not going to use the B coordinates just in case I've made a mistake, so I'm going to use the ones that I've been given, and we're going to look now at the gradient of AM. That is the change in y, so if we look at the change in y, 7 minus 1 So I've taken the y coordinates and then that's over 2 minus 0. So we've got now 6 over 2, which is going to give us 3. That's the gradient of the line through AB, therefore it will be the gradient of the line through C. At this stage we can simply plug these values into the equation of a straight line in the form y is equal to mx plus c. The nice thing is here is that it goes through the y-axis, which means we could simply write that y is equal to the gradient, which is 3, multiplied by x plus the 13. So if you were unsure about the 13, of course you can simply sub in the values. So y would be equal to 13, the gradient is 3, the x coordinate is 0, plus the c, so we can see c is 13. But remember, the value of c is the y-intercept. So it's just a case here of just writing y is equal to 3x plus 13. So quite a nice little question and fairly logical once you've done it. We can see now that this right angle here, it's just a straight line we move across. We're told the line L with equation 3x plus y minus 9 equals 0 intersects the line M with equation 2x plus 3y minus 12 is equal to 0 at the point A as shown in the diagram above. So here's A. In part A we need to, as exact fractions, find the coordinates of the point A. So what we're looking at now are simultaneous equations. So this is equation 1, this is equation 2. Lots of different choices. What I'm going to do is just write now that 3x plus y is going to be equal to 9. I'm going to add 9 to both sides. Equation 2, I've got 2x plus 3y will be equal to 12 by adding 12 to both sides. At this point I'm simply going to multiply equation 1 by 3. So if I do that, equation 1 becomes now 9x plus the 3y is going to be equal to 27. I've looked to make the y's the same so we can eliminate. So if I do equation 1 minus equation 2, we're going to have 9x minus 2x, which is 7x. The y's are going to cancel, and we're going to end up now on here with 27 minus 12, which is 15. So the x coordinate will be 15 over 7, and that is the exact fraction. We now need to take this and solve for y, so putting it in any of these, I'm going to put it into equation 1. 3x plus now the y is equal to 9, so we can say 3 lots of 15 over 7 plus the y is going to be equal to 9. That's going to give me 45 over 7 plus y, and I'm just going to write this now as 63 over 7. So we can say that y is 63 over 7 minus 45 over 7, which should be 18 over 7. So that now gives us the coordinates. So this point right here, if we look at it now, we can say that A has the coordinates in exact form or exact fractions 15 over 7, comma 18 over 7. And that's that part done. You could have solved those simultaneous equations all manner of different ways. So I could have written this one as y is equal to negative 3x and then plus 9, and then simply substituted that in for y there to eliminate y and get an equation in x. It's entirely up to you. I've just gone for this way of elimination rather than substitution. Next part, we're told the region R1, which is just here, is bounded by L, M and the y-axis. The region R2 is bounded by L, M and the x-axis. In part B, we need to show that the ratio of the area of R1 to the area of R2 is 25 to 18. Okay, this really is a nice extension question. So what we're looking at here are these points here, and we're looking at these points here. I'm going to find the area of this triangle R2 and find the area of the triangle R1. When we have lines, like so, these will cross the x and the y-axis. So let's take line L. This is line L. It will cross the x-axis when y is equal to 0, and it will cross the y-axis when x is equal to 0. So if we look, what we're going to have, and I'll just jot this down, so this is L. So when x is equal to 0, we're going to have y minus 9 is equal to 0, and that will give us that y is equal to 9. So if I put this on here, what we're going to have is this point right here. So for this line, when x is equal to 0, y is going to be equal to 9. If we now look at this point here, this is where y is equal to 0. So if y is equal to 0, we can say that 3x minus 9 will be equal to 0. And we can say that x is going to be equal to 9 divided by 3, so x would be equal to 3. So what we're going to have then is this point right here, and this is going to be on here, we're going to have 3, 0. So let's go ahead and put that on. That will be 3, 0. Let's now look at the line M. So this is going to cross, and I'll write it just here. We're going to have now on here, let's get rid of that, that's a bit messy. We're going to have now M. So if we think about M, when x is equal to 0, 3y minus 12 will be equal to 0. Adding 12 divided by 3, y is going to be equal to 4. So what we've got here now is this particular line. When x is equal to 0, which is just here, so there, we've got y is equal to 4. If we look at this point right here, that is when y is going to be equal to 0. So we can say now that 2x minus 12 would be equal to 0. Adding 12 and dividing by 2, x is going to give us 6. So what we've got then is the following. So if I put that on here, this is going to be now 6, 0. So we know that this point right here has got the coordinates 15 over 7, 18 over 7. All I'm going to do is look at 2 different triangles. I'm going to look at this triangle here, and that has a base of 5. That's the difference between the y coordinates. And it has a height of the x coordinate just here. So all we need for the triangle is a perpendicular height, which is this distance here, and the base. So if I look, what I can say at this stage now is that R1, and we'll write this here, so we can say that the area R1 is the area of a triangle, which is 1/2 the base. Well, the base right here is going to be equal to 9 minus 4, which is 5, multiplied by the perpendicular height. The perpendicular height is going to give me now the 15 over 7. It's the x coordinate just here. So we can write this as 15 over 7. So that's going to give me now, what are we going to have? We're going to have 5 times by 15, which is 75 over now, so 75 over 14. So that's going to give me 75 divided by 14. So that is the area. Let's just tidy that up a little. So then 75 over 14, and let's put that in. We want the blue one. There we go, 75 over 14. I can't do anything with that. Let's now look at the area of R2. So if I put this on R2 now, this is going to be the area. We've got another triangle. This time the triangle has a base, and if we put this on, let's go ahead and we'll try this one. So that's got a base here of 3. We've got the triangle just here like so, and it has a perpendicular height now of the y coordinate of the point of intersection. So that's just this height, and that's the 18 over 7. So let's go ahead. As you can see, this really is quite a nice bit of extension work. So we're going to have 1/2. This is the area of triangle, base, which is 3, multiplied now by the height, which is going to be 18 divided by 7. So what we're going to get on here is the following. If I look at this, I could simplify this, but what I'm going to write is that this is going to be now 54, that's 3 times 18, over now the 14. So if we look at this now, we can say as an unsimplified ratio, we've got R1, so we've got R1, I'm writing it on here, so R1 to R2 is going to be 75 to now the 54. I'm going to divide both of these by 3, dividing that one by 3, and that's going to give me 25 to 18 as required. So really quite a lovely little question, but at the same time lots to think about on that, and a good understanding of geometry would help. That's one way that you could answer that question. It's certainly not the only way, but it is one way that you could do it. Okay, I think we've done that one, and nothing more to do. Let's have a look at one more. The straight line L passes through the points A, 1, 2 root 3, and B, root 3, 6. We need to find the gradient of L in its simplest form. So this time we're dealing with surds. So what we can say then is M, and often we can write MAB, the gradient of AB, or ML. So it's for change in y, so that's going to be 6 minus the 2 root 3 over the change in x. So I'm going to have 6 minus 2 root 3, and then we're going to have root 3 minus 1. We need to give this in its simplest form, so we need to rationalise the denominator of this fraction. So as we've seen before, we multiply now the numerator and the denominator by what we call the conjugate. It's the same numeric values, we just switch the sign, and this creates the difference of 2 squares. So if we now expand the numerator, we're going to have on here, and in fact I'll just, for now I'll just leave this as it is. I'm going to just leave it as it is. We'll have 6 minus, then we'll have 6 minus 2 root 3, and then we're going to have on this one root 3 plus 1. I'll leave it as it is, and then we'll expand the denominator. So we're going to have root 3 times by root 3, which is 3. We're going to have plus 1 lot of root 3. We're going to have minus 1 lot of root 3, and then we're going to have now minus 1. I'm just going to factor the numerator slightly. I'm going to take out this common factor here of 2. That's going to give me 2. Then we'll have 3 minus the root 3, and then we'll have now root 3 plus 1. If we look in the denominator, these terms are going to cancel. We've got 3 minus 1, which is going to give us 2. So we can simply write that this will be 3 minus root 3 plus, multiplied by root 3 plus 1. So really quite tough. But again, that's in its simplest form. I wouldn't expand it. I mean, we could do if we really wanted, find the gradient if we wanted to expand it. Let's see what we're going to get now if we multiply this out. 3 root 3, then we're going to get now plus, so we're going to have plus 3, then we're going to have minus 3, and then we're going to have now minus root 3. So this actually will work out quite nicely because they'll simplify, and that's just going to give us 2 root 3. So yeah, I mean, certainly look to expand it. I didn't looking ahead, I should have probably expanded that, but that's what it's going to give us if we do that. So that's in its simplest form. We need to show that L also passes through the origin. So let's go ahead and do that. What we need to do here is get the equation of a straight line. So if I look at this point, we got point B. For the equation of a straight line, we need 2 things. We need a point that it goes through. I'm going to choose B. Of course, you can choose A. And we need now the gradient, which is M. And the M we found to be 2 root 3. So if we sub this into the equation of a straight line, y is equal to mx plus c. All I'm going to have in this case is now the following. Substituting in the 6, that's going to be equal to 2 root 3. Then we're going to have now multiplied by the root 3, and then we're going to have plus c. So this is going to give me 6 is equal to 2 root 3 times by root 3, as we see before, is 3 plus c. So 6 is equal to 6 plus c. That gives us now that c is equal to 0, therefore the y-intercept is 0. So y-intercept is 0. So y-intercept equals 0, therefore passes through the origin. So passes through origin. And that would be sufficient. So through the origin. Just think, if we have y is equal to x, that passes through the origin because we got plus 0 as c. You might want to even put it back in and show for one of the coordinates it does. I think that would be perfectly sufficient. We need to show that the straight line which passes through A and is perpendicular to L has equation x plus 2 root 3y minus 13 is equal to 0. So let's look at point A. Point A is 1 comma, so let's write this here, 1 comma, and then what did we have? 2 root 3. So that's the point L. So if we look at this now, what we've got is the following: 2 root 3, 1 and 2 root 3. Now if we look, this is M1. So we can write now M1 is going to be equal to 2 root 3. Therefore, we can say that M2, the gradient of the perpendicular, and they've used the word here, the straight line which is perpendicular, so we can see that is going to be the negative reciprocal. So I can write this as negative 1 over 2 root 3. So that's what I'm going to put in here. I could leave it like so. I'm just going to leave it like so because I'm going to write on here now M1 is 2 root 3, therefore M2 is negative 1 over 2 root 3, as we can say now that the 2 lines are perpendicular, as 2 lines perpendicular, and product of gradient is going to be equal to negative 1. We've seen this before. Product of m1 and m2 will be equal to -1. So just jotting that in. So what we've got then is this right here. And we can substitute this in to the equation of a straight line. We can either use y is equal to mx plus c, or we could use y minus y1 is equal to m, the gradient, multiplied by x minus x1. I'm actually going to, for once, use this particular approach. You can, of course, use this one. It is entirely up to you. What I'm going to do is say now that y minus the y coordinate, which is 2 root 3, will be equal to 1, and that's going to be -1 over 2 root 3. Then we're going to have now x minus 1. So this is the line. We need to put it in this particular form. So what I'm going to do at this stage is multiply both sides of the equation by -2 root 3. That's going to give me -2 root 3 multiplied now by y. Then I'm going to have plus the -2 root 3 multiplied by the -2 root 3, and that will simply be equal now to x minus 1. So we get -2 root 3y, or if we want, we can, what have they got it in? That's perfectly fine, they've got it in that form. We can say -2 root 3y. Now, if we look at this, we've got two negatives, which will give us a positive. This is going to give us now 2 times 2 is going to give us 4. Root 3 times by root 3 is going to give us 3. So 4 times by 3 is 12, and that is equal now to x minus 1. I'm going to add now the 2 root 3y to both sides and subtract 12. So the left-hand side will be x. We're going to have plus now 2 root 3y and subtracting the 12 minus 13 as required. So that's what they wanted us to do, and we've gone ahead and done it that way. As stated, you can put it into this particular form. I just think it's slightly easier to work with it like so. So that certainly is quite a nice advanced extension question for you. So first two were probably realistic top-end exam questions, and then the next two were a bit of further work if you wanted it.